So today we are going to learn few tips and tricks in C programming. This is especially useful for those who are going to attend software interviews, campus placements, because these kind of questions are typically asked in these interviews. The first example is how do you swap two variables in C without using a temporary variable? The first solution is to uh, store the intermediate value. We add the two variables and store it back into the first one. Subtract the second from the first and store it on the second. And then subtract the second again from the first and store it in the first. This method can be used, but this has a flaw. This might cause an overflow. When you are adding two variables, it might cause overflow if the result is more than 32 bits. So another method which can be used is XOR. You can XOR the variables one after the other in the steps shown below, and you can swap them. Suppose the variables are A and B. You first XOR A with B, store it in A. Again XOR A with A, store it in B. I'm sorry, you XOR B with A, store it in B. And finally you XOR A with B and store it in A. You can try this out yourself and see whether really the variables are getting swapped. The next one is how to do fast multiplication and division by powers of 2. Now to multiply a number by 2, you simply left shift it by 1 bit. And to divide a number by 2, you'll right shift it by 1 bit. Let us say you want to multiply by 8, you left shift it by 3 bits. 3 is 2 power 3. Sorry, 8 is 2 power 3. That's why you left shift by 3 bits. It gets multiplied by 8. Bit shifts are generally faster than multiplication or division. So this is generally preferred. Okay, next example is how do you check if a number is even or odd without using the modulus operator? So simple solution is you just check the LSB. If the bit 0 is 1, the result is odd. If the bit 0 is 0, the result is even. So without using modulus, modulus involves a division, which is a very expensive operation in embedded system. You can just look at the least significant bit of the number and decide even or odd. Okay, the next operation is how do you find min and max of two variables without a branch? Without a branch, or you can say without an if condition. There is no comparison involved here. So for example, if you want to find the minimum of two numbers A and B, you will just use this operation. You can carefully see we are returning B plus A minus B, which is ANDed with A minus B right shifted by 31. A minus B right shifted by 31 gives you the sign bit. If the result were negative, and the result will be negative when A is less than B. If A is less than B, you AND it with all ones. ANDing with all ones means A minus B ANDed with all ones is A minus B. So you add B to A minus B, the result will be A. Since we started with the proposition that A is less than B, you got the result as A, which is the minimum value. Similarly, for the maximum, you do A minus B and it with the sign bit. Now assume again here A is less than B. If A is less than B, A minus B right shifted with 31 bits is all ones. Now A minus B ANDed with all ones is A minus B. When you subtract A minus B from A, you get B. So the maximum value will be B. I will show you a C program where all of these operations are implemented and we can check the results later on. The next one is how to check if a number is a power of 2. A number will be a power of 2 when there is a single 1 in the entire bits. If you convert the number to bits, zeros and ones, and if you count how many ones are there, there has to be a single 1. Only then you can conclude it is a power of 2. What that means is that number ended with number minus 1. Number minus 1 will be all ones. Let us say the single 1 in that number was in position number 6. So what the number is? Number is 2 power 6, which is 64. Number minus 1 will be 63, which will be all ones starting from bit number 5 to 0. So when you add these two, one bit in bit number 6 and all ones in bit number 5 down to 0. When you add these two, the result will be 0. So that's the beauty of powers of 2. This does not hold true for any other numbers. So this check can be used to decide whether a number is a power of 2 or not. We don't have to check or we don't have to count all the bits. We don't have to go through all the bits in the number to check whether it is a power of 2 or not. So this is a simple operation which can be used. X and x minus 1. If it is if it is 0, the number is a power of 2. An example is given here. For example, 8. In binary, it is 1 followed by 3 zeros. And 8 minus 1 is 7, which is 0 followed by 3 ones. When you add these two, the result will be 0. So this means this number is a power of 2. Next example is how to count the number of bits or the number of ones in an integer. The simple answer would be to go through all the 32 bits, keep checking if it is a 1 or a 0, and have a counter. But that even if the number is having 1 bit set, you will have to go through all the 32 bits. So another solution will be you keep clearing the LSB and keep a counter. So this loop will run as long as there are ones in the number. For example, if the number that you have is 5, 5 is 101. The first time you run the loop, you add 5 with 4 and increment the count by 1. When you add 5 with 4, the result is 1. Next time you run the loop again, you will add 1 with 0. The result is 0. The count becomes 2. And since the number has become 0, you automatically come out. And you have the count of 2, which is the number of bits, number of ones in the number. So this loop will run as many times as there are number of ones in the number. So this is an efficient method which can be used. Next one is how to find the absolute value of a number. So the solution is you find the mask. Mask is just the sign bit. You find the sign bit. You add the mask to the number and XOR with the mask again. For example, shown here, let's say the number was minus 107. The mask will be you shift right the number by 31 bits. When you do that, the sign bit gets extended to all the other bits. So you get 31 ones, which is all FFFF. So to the number minus 107, you add all FFFF and XOR with all FFFF. You will get the result as plus 107. So this method will work for both positive and negative numbers. This can be used to find the absolute value of a number. Next one is how do you reverse all the bits in an integer? For example, let's say there is a 32-bit integer. You want to flip all the bits. The simplest solution will be to go through each and every bit and keep on swapping it and form the new number. Bit number 0 goes to bit 31, bit number 1 goes to bit number 30, bit number 2 goes to bit number 29, like that. But another beautiful solution is shown here. First, you swap only even and odd bits, one bit at a time. In the next step, you swap two bit pairs. The third step, you swap four bit pairs, which is the nibbles. Next one, you swap eight bit pairs, which is the byte. And finally, you swap the 16 bits. So with this six operations, you will be able to swap all the bits in the number. I will show an example where this is demonstrated. The next one is how to find the length of a string. So instead of using a custom function or a library function, you can write your own function like this. So what this does is you assign your string pointer to another local pointer s, and you keep on checking. So you are increasing the pointer. So first it is pointing to the start of the string. Next it is pointing to the next character in the string until it reaches the end of the string. Then finally you subtract the two pointers. The first pointer str is pointing to the start of the string, and finally the string s is pointing to the end of the string. So difference in the two pointers is the length of the string. So this is without using any internal functions. The next one is how do you do debugging with macros? You can use macros like this #def debug. You can define a macro log message which expands to printf with your own custom string message, which is useful for you to debug. And if the debug is not defined, the log message is left undefined. So in case you can have in your program, you can sprinkle this log message all over the place for your debug. And then whenever you don't want to enable the debug, you can just not define the debug flag during compilation, and all the log messages gets disabled. So this is a useful technique to debug as well as have the same code and disable the debug. Next example is how do you zero an array efficiently? Let's say there was an array of 100 integers. One method is you do for loop, run it 100 times and initialize each element one by one. Another efficient method is do memset. This is a library function call. Memset, you give the starting pointer of the array and set it to 0. So this will fill all the entries to 0. Another method is at compile time, when you initialize the array, you declare it with value 0. This will initialize the entire array to 0. Next one is ternary operator. This is one of the important questions in interviews. Ternary operator. So this consists of a condition followed by a question mark followed by one result colon followed by the second result. So what this means is if this condition is evaluated to true, it will return the first result. If it is evaluated to false, it will return the second result. So in this case, this is a max example, finding the maximum value of two numbers. If A is greater than B, it will result A. It will give out the result as A. Else it will give out the result as B. So this is equivalent to these lines of code. So it is a compact implementation uh, of the same thing. Next one is if you want to access some hardware registers, it is always advisable to use the volatile keyword because the hardware register values keep changing without your software knowing about it. So if you want to access that register and if you want to do some modifications, something about it, something on that register, it's always advisable to grab the latest value, do the modification and write it back. Don't rely on the value which you had read it earlier. That's why the volatile keyword is very important. It will remove any software optimizations in the code. This is very, very important for hardware registers. The next example is how do you do fast modulo for power of two devices. So whenever you want to do modulo operation, let us say there is a power of two divisor. For example, you want to do modulo 32. What you will do is you will AND it with n minus 1, which is 31. So that will give you the modulo. You can check it out. It's a very fast and simple technique. Next one is static assert. So you can use assert in your code. For example, this static underscore static assert condition comma hash condition can be used. Hash condition is a string message. So if the condition is not true, it will display the string message. So you can use it like this in your code. So it will throw an error at the compile time. It does not even let you run. It does not even compile the code if the condition is false. So this is also a useful technique whenever you are not sure if something is not right, you can put it. So if the compiler will check if something is not correct, it will throw an error immediately. Important takeaways in this presentation, we learned about some of the bit hacks to optimize critical code, macros, how that can be used for logging, enable message logging in your code, constant volatile to improve safety and for hardware control, and pointer arithmetic simplifies array string operations. We will demonstrate all of these things with a simple example. Let me show you that. I have an example here, it's example program hello.c with the same thing that I have explained here, finding the minimum of two numbers as I had shown, maximum of two numbers, custom string length to reverse the bits of a number. Then this is the main function. First, I just print a hello world message. Then there is a static assert. If this condition is not true, it will throw an error during compilation time. So to find the min and max, I have two numbers. One is minus 109, second one is minus 507. So I use my two functions to check whether minimum and maximum are found correctly or not. Then to check the length of the string, I have the string called hello world. Its length is 10. So I call my string length custom function to find whether it is giving the correct string length or not. And lastly, to reverse the bits of a number, I have taken this number and I will print the reverse number using the function that we wrote. And then we will check whether it is giving the correct reversed bits or not. So let me just clear my screen. I'll compile the code. So let me clean it. Okay, let me run it now. Okay, so this is the print message. The minimum is minus 507, maximum is minus 109, which is correct. String length is 10, which is correct. The input number and the reverse number are these. Let's quickly check whether they are correct. The input number is this. The reverse number EB7BEF98. You can easily see all the bits have been swapped. 1011, 0111, 1011, 1110, all ones, 1001, 100. So everything is correct now. Thank you. Thanks a lot for your attention. You can like and subscribe and comment if you would like to have such more tutorials with you. Subscribe for a wider audience. Thank you.